Hello, everyone. Okay, I think we're live. So welcome back to the Cloud Intelligence Workshop 2021. Um, this is
Yes,
this is
the
the,
remaining until there is still 1 minute. That's what it's showing. Backstage is live.
oh, sorry. Wait, is that right? No, I think
That,
that's time remaining until the event ends. So I believe we are live.
sorry.
Okay, yeah, that's a minute timer. So I just wanted to, okay, welcome everyone to our panel on cloud intelligence across academia and industry. So we're going to spend the next hour or so talking about cloud intelligence in industry as well as in academia and the research we're doing, and how we can try to bridge the gap between the kind of work that's being done in universities and at companies. I have a very star-studded cast here of panelists that I'm really excited to introduce to you, and they span industry and academia. So I'm going to go ahead and introduce each one of them briefly. I'm not going to give you their whole bio or history or all the accolades and awards they've won, because that would take us hours. They've done so much work, but I wanted to give you a brief overview. And some of them you've met already if you've attended previous sessions. So going down in alphabetical order, we have Rama Akiraju, who is an IBM Fellow, Master Inventor, and IBM Academy member at IBM's Automation Division, where she is the CTO of AI Operations. Rama has led AI missions for enabling natural, personalized, and compassionate conversations between computers and humans, and delivering unique AI services to the IBM Watson platform, like personality insights and emotion analysis. Next, we have Christina Delimitru, who is an assistant professor and the John and Norma Bellin Sesquicentennial Faculty Fellow at Cornell University. I had to look up that word, sesquicentennial. I don't know what it means, Christina. Maybe you can tell us later. Where she works there on computer architecture and computer systems. Her research focuses on improving the performance, predictability, and resource efficiency of large-scale cloud infrastructure by revisiting the way these systems are designed and managed. And you've heard from her earlier. Jim Cluin is a technical fellow at Microsoft, has spent over 15 years in the company working on Office servers and services. Yeah, please raise your hand and say hi when I introduce your name, if you can. He began working on the lower layers of the Exchange server stack, and then so like indexing, data storage, high availability, and disaster recovery. And then he rose and ascended to the heavens to work in the cloud with Office 365 and helped them establish the architecture and implementation of that service. Next, we have Martin Maas, who's a senior research scientist in the Google Brain team. He's primarily interested in managed language runtime systems, operating systems, and computer architecture, and his interests span the entire stack, from hardware to programming systems layers. At Google Brain, he's working on topics related to machine learning, and he's also thought deeply about how and when we should apply machine learning to systems problems. Our final panelist could not make it with us due to an medical emergency that she's recovering from, but I wanted to introduce her anyway. Her name is Neeraja Yadwakar, and she's a postdoctoral research fellow in the computer science department at Stanford University, working with Christos Kozirakis. She's a cloud computing systems researcher with a strong background in ML, and her research focuses on developing ML techniques for systems and building systems for ML as well. So unfortunately, Neeraja could not be with us, but we have our 4 other panelists. So I'm excited to get started. The goal of this panel is to have a fun, relaxed conversation about intelligence in the cloud, and also think about ways that industry and universities can collaborate. So I wanted to kind of kick things off by asking our industry panelists, and as well as our university panelists, but I wanted to ask the question of how you think as a whole people perceive AI in your organization. Do they view it as a tool, a last resort, an unreliable optimization? I realize this might vary from group to group, but I want to get an example of how your team might view it. So if any one of our industry panelists wants to take that, please feel free to start.
Well, I can jump in and start with that one, Sid.
Okay.
And I think the best way to characterize it right now is a mixed bag. It really depends on the team. And let's be honest, the individual. In some cases, it's the first choice. It's people's go-to tool for solving cloud automation problems. And sometimes it's crammed into places where it's really not needed or appropriate, just to be one of the cool kids. Because, you know, everybody wants to be doing AI. The cool kids want to be doing AI. So some people try to cram it in. And on the other extreme, it's unreliable snake oil to be avoided at all costs. It's often non-deterministic, and a lot of what we offer is like spooky and creepy and wrong. So it's really highly dependent on who the individual is and what the team is and what they're working on. And the real challenge is to build the knowledge, skills, experiences about where, when, and how to use AI. It's a great tool in our toolbox. It's the right tool for many situations, but it's the wrong tool for others. And as an industry, we don't yet have patterns in industry-wide knowledge and institutional experiences to know when it's appropriate and when it's not.
Right.
I'll shut up and let somebody else talk, but it really is a mixed bag.
That makes a lot of sense. And you talked about when it's appropriate to use AI and when it's not. Martin, do you want to make a comment on that? I know you wrote a recent paper about trying to help people decide when they should use ML and when it's not appropriate. What are your thoughts on that?
Yeah, thanks, Sid. That paper was called Taxonomy of ML for Systems Problems. And it's exactly about this topic that sometimes, so you can apply machine learning to pretty much any problem you want. You just basically give it enough training data and you train a model and you can learn that problem end to end. But the important question is, what is actually the step function difference that machine learning gives you? Like, what is the thing that the model actually learns you couldn't encode in a heuristic? And so the take of that paper is basically to say what machine learning really allows you to do is to go from a heuristic to a data-driven approach where you make decisions based on the actual data that a system encounters. And so the approach this leads to is to basically break down your problem and figure out what is the part of the problem that actually is data-driven, and then just build traditional heuristics around it. To Jim's point, this is an instance of basically figuring out when is machine learning the right tool for the job and which things are better handled with heuristics. And then you break the problem down to these different pieces and use machine learning where it's the right tool, and you use traditional techniques for everything else.
Got it. So I really like this idea of decomposing the problem down. I am a strong believer in that because I think it's an opportunity to use heuristics in some places, machine learning in some other places, and just classic human solutions in others. So Rama, I know you talked a little bit about this in your talk about the debugging process and using AI techniques to help there. Could you comment a bit on the blend of AI versus kind of homegrown human solutions that appear in that process?
Well, yeah, sure. So there is a lot of heuristics. There are a lot of heuristics, and there are a lot of policies that are already set up in many organizations, right? And those have been distilled by the subject matter experts in the organization over several years, and they have a lot of this tribal knowledge in their heads, and they have codified that into rules, and that works out quite well for many companies. There is nothing wrong with continuing to use those. The challenge becomes when those people, either retire or walk away from the company. Then you are left with rules that you don't know how to update, how they arrived at those rules and those policies, and how to maintain them, and how to make it more data driven, as Martin was saying, as opposed to being tribal knowledge driven. And that's where AI and ML can really come in handy, where, if you have those subject matter expertise, yes, you can codify them as rules. But it would be nice over a period of time if you're able to collect enough data for the systems to learn those from data itself, so that you don't have to manage these rules over time, and the systems will automatically learn the patterns from data, and especially as things change, patterns change, data drifts, seasonality kicks in, all those things, the data changes or customer preference changes, the systems will be able to adapt better. So that's the advantage. But I still think, rules, subject matter expertise have a very important role to play, and they should continue to be there. In fact, they should be used often, and this turns out to be the case, that you need those rules, in fact, even on top of machine learning models, to bridge the last mile problem. Because you can learn from data, but some long tail types of patterns, you cannot, there is never enough data for systems to learn from that data. So you still have to bridge the gap with those rules. So both of them have a role to play. But if you can, over a period of time, collect enough data, then it's good to let the systems learn so that they can become more adaptive. That's what
Yeah, I really like that point about the need for both. These rules are pretty hard to replace. At least in my experience, I found that sometimes they're hard to replace. Sometimes they're also needed for safety. And we can talk about safety a little later as well, because I hear what you're saying, that there's a lot of kind of domain knowledge and experience going into them. And I also like what you said about people leaving, because that's hurt me in the past quite a bit too. When people just leave and move companies, and then you lose this context, and sometimes you even lose a project because the person driving it on the product side, for example, when I'm trying to collaborate across research and product groups, just left. So Christina, I wanted to ask you if you've had any experience with this dilemma that kind of Ram was talking about between rules and heuristics that would work, and the thought of applying AI to a problem, and if you have been able to find a balance or not.
Yeah, that's a good question. So I agree with everything that's been said so far. There are cases where heuristics make sense, and there are cases where the system is so complex that you need something like ML or AI. So obviously I'm in an academic environment, so I don't see cloud providers from the inside, but I have collaborated in the past several times with cloud providers, including integrating ML approaches to system management. So my viewpoint is skewed because the kind of problems that we look into are the kind of problems where heuristics break, and you need something more automated that abstracts away the complexity. So whether that is having a hardware system that's very heterogeneous, at which point you don't want the user to be tasked with figuring out what application goes where, or even programming the applications, or whether it's cases where the applications are so complex and you have hundreds of components talking to each other, where again you don't want to task the user with managing that complexity.
Right.
So I think it's a key point that in all this kind of work, at least again from an academic perspective, it's important to compare the two and make a strong case for why you need ML or AI, because you lose something by using ML, which is you lose the explainability that more analytical or even empirical approaches have. So there needs to be a strong reason why it's being applied.
So all of you have kind of touched on this question of like, when do I pull the trigger and decide that ML is the right approach to use? Some things I heard were things like if it's too complex, or if it's too heterogeneous, or if there's something that'll be very computationally difficult for like humans to do. Does anyone want to comment on the maybe the key thing they look out for when they're trying to decide if they should use ML? And I guess the reason I ask this question is because I'm often, when I'm faced with a problem, I often try to think about what the strongest human or non-ML solution I can come up with is, or I try to look for one first, and I spend a lot of time on that before I even use ML. Is this something that you do in your experiences? Does anyone want to comment on that decision of when to kind of pull the trigger and say, okay, let's start looking into ML techniques for this problem?
Yeah, I can go, Sid.
Yeah, go for it.
What you said is exactly how we approach it, and I for me, if I can't take a small amount of data and by hand solve the problem and figure out the patterns, it's very hard to say whether a system in AI model can do it or not. We have to have some level of, first order of intuition saying, yeah, there are some patterns and there is a model that we can fit here, and there is enough data that is actually there in this. Therefore, it might be, using statistical machine learning might be an approach. But then another factor I look for is also what are the kinds of features that the system might be able to detect in the data. Is it all unstructured data, or is it semi-structured? Is it structured? If so, are we talking about, would the system be able to pull the tokens, word embeddings, those sort of things, and would those be the features that the system will use, or would it be, the text, any other textual features and those sort of things? What are the patterns that the system might be able to learn from? At least have some sense of it before deciding whether it's a good candidate. And another thing I definitely absolutely look for is what is the freshness of the model. If we build a model today, you cannot expect the same model to be making predictions 3 months from now, 6 months from now, a year from now. So is there a constant steady stream supply of fresh data that's coming into the system so that the models can be regularly refreshed? And is there a mechanism for that continuous learning? And is that set up? And if we don't have it, and if it's a one-time bootstrap data that we just get and build a model, I think it's not at all worth it, because those models, they may be good initially, but then they get stale very soon. So that data pipeline and having that whole model management lifecycle thought through, that is very important before you get into it.
So, this idea of creating that platform and that cycle is something that, I've worked on quite a bit too, because as you said, you don't want to set all this infrastructure up for point applications and have to constantly redo it. But I think that's a tough one. I don't know, Jim, do you have any experience with working on ML-like solutions and having to kind of reinvent the wheel each time, and feeling that was a pain point?
Well, number one, when I think about solutions in the space, I mentally differentiate AI from ML. And a lot of people group them together, and I don't, because in AI, you can produce a model, and the model's durable, and it's complex, and it's dealing with a multidimensional problem, and you don't have to retrain it very often, if ever, because it's representing something that's reasonably durable. That's a use of AI. And I use as the quintessential example of that something like the Kinect controller for the Xbox game device. That's got an AI model in it to attempt to detect, the human motion that's going on and create a wireframe from that to decide if you're running or jumping or, swooshing with your badminton mallet or whatever badminton calls it. And it's a reasonably good use of AI. You build the model once. It's a complex, difficult thing, hard to do with traditional programming. You can bake it into the device. ML, you have to have the feedback loop. There has to be learning for it to be ML on an ongoing basis in my ontology. And when I look at problems, I say, is this a problem I should solve with a traditional approach? Is it a problem I can solve with AI? Or is it a problem that I really need ML to solve? And for ML, then I look and say, what's the feedback loop? How do I get the data? How do I get the data curated? And in real production systems, gathering new instances of the same data is pretty easy. Gathering volumes of it is pretty easy. In fact, in a lot of cases, we got to worry about how to filter the data not down, not how to get more. When you process billions of transactions a second, you don't worry about gathering too much. You don't worry about gathering too little. You worry about gathering too much. It's when the data that you need changes that it starts to become more challenging and more painful, because you can't just roll out a new change to 4 million servers worldwide in a 3-minute period and say, "Yay, we're gathering new data." You've got to stage the introduction of the change that collects the new data out over a certain period of time so that you can safely deploy the change, and you have to be able to roll back the change in case bad things happen, and all of the things associated with running a continuously available live site. So gathering the same data, new instances of it, easy peasy. It's when you have to change the data that you're gathering, collect new data, collect new variations of data. That's when it starts to be a real challenge.
So So I think the distinction you're making is about that continuous cycle and having to cope with changes that happen in the environment. Versus, I like that example of the Kinect controller, where yes, that could also maybe adapt and learn new things, but for the most part, if it's been trained well enough, you can just set it and forget it. And I guess this is what Ram was talking about in terms of freshness. So there's some problems where you do one job right, and the world doesn't change from the perspective of that solution, and it just kind of works. And then I think you're talking about non-stationarity, which I think all of you are talking about as a problem. So yeah, let's take a second to talk about that. How do you cope with non-stationarity, or can you give an example of an AI system you've worked on? Anyone in the panel where you've kind of had to deal with non-stationarity or this kind of changes in the world or in the data, and how do you cope with that?
I can go, and I know Martin and Christina didn't get a chance. I'm sorry, but I'll drop off at the top of the hour, and please feel free to.
Yes, I will. I was gonna.
The rest of the half
Go
hour.
for it.
Yeah. So the example of somewhat stationary and more dynamically changing AI models, right? So I'll give a classic example from things that I have worked on. if you build, let's say, a speech detection model, let's say for well-spoken domain, say news reading domain. Say you want to build a news reader which can do text to speech. You can record and train a model with voice actors as voices, and you don't have to change it that often. Once it's trained well, it's well written text, and as long as the text to speech can speak in a male and a female voice in 5 or 6 accents. Let's say I'm only talking about one language, let's say English, UK English, American English, Australian English, and a few variants like that. That's for a really long time you don't have to change it because it's been trained, it understands English language, and that's pretty stationary. You don't probably have to update it that often, right? But now let's say you're building a chat bot, and the chatbot needs to, for a customer domain, customers call in from different locations, with background noises, and especially if you're ordering, let's say in a fast food restaurant, they're building text-to-speech automatic order taking system. Kids are, making noise in the background in the car. Dogs barking, traffic, when they pull the window down, traffic signs going, everything. And people speak in different accents, and your menu might change over time, right? So for that, if you're building a speech to text recognition system, it has to really adapt to people's accents, all those background noises and such, and and the menu changes and everything. So it has to keep on, whenever those variants change, it has to adapt. So those are the examples of where it could be one AI model could be reasonably stationary, but another one which has to be constantly changing and adapting to the needs and requirements and environment.
I love those examples. They make a lot of sense to me. I like the stationarity of language. Yeah, it changes, these days, but it's not. It doesn't change. It's much more stable.
The news reading one, because that tends to be hopefully somewhat formal, decent, and stationary. But if you're talking about social media conversations and those sort of things, then the lingo is changing by the minute every day, so that becomes hard.
It's interesting. I was going to say that even though it's like the lingo is changing, I still view it as much more stationary than other things. But that's just how I think about language, I guess. So that's an interesting example. Martin or Christina, do you have examples of non-stationarity in the work you've done and kind of how you had to cope with that?
Sure. I can give you an example similar to the system I talked about in my talk, which is applying ML to performance debugging. So this is specifically aimed at new types of cloud applications where you have dependencies. So this is microservices or serverless frameworks for those that are in the area. And the idea is that the application is so complex that you don't really want to task a user with figuring out where the performance issue is. So in that case, you definitely have to collect data, if not on a daily, definitely on a weekly basis, because the user patterns change. But the more challenging aspect of that is that the actual application changes. So you can have new components that are added, you can have old components that become obsolete, and that changes the model. That is not just about retraining the model, that is actually making the model amenable to changes in the application and the underlying hardware. And to a large extent, that affects what kind of ML techniques you can use. For example, if you have to collect the training data set every time you need to retrain the model, and you're using supervised learning techniques, you have to do some labeling of the training data set. For the specific use case, the way we collect the training data set is by injecting performance issues into the system, which if you have a test cluster and you only need to do it once, that's fine. But if you are in a production system, you can't really affect the performance of a live application that quickly. So that pushes you towards unsupervised learning. So definitely how frequently you need to retrain, but also how frequently you change the model applies a lot to the kind of work we do.
Mm-hmm. Martin, do you want to add to that?
I got a similar example as well. So we had some work recently on machine learning for storage systems. And so the idea there is that you have these distributed traces in data centers where you have tags attached to each request as it travels through the system. And you can learn storage properties from those, like what is the lifetime of a file, for example. If your distribution is stationary, you can just build a lookup table and have a very cheap way to to basically look up that information, but that lookup table would drift over time. And so what we did in this work was we built a hierarchy of models, where we had this very cheap lookup table, and then we had increasingly complex model like a nearest neighbor-based approach, all the way to a transformer model, which is really more like a language model that you can apply to new text that you haven't seen before, and then update the lookup table based on that. And so that way you avoid this drift over time by basically re-updating your lookup table with the more expensive model that is more robust towards the shifts.
So how did you decide which ones to use? You created this hierarchy. How did you decide which ones to use when?
It's basically like a cache. So your lookup table is basically, if you're missing the lookup table, then you would need to use the more expensive model.
Like a cache. I see. So, so maybe one question. I know Rama's going to leave soon, but Jim and Rama, do you have when things change in the ways you've talked about, these non-stationary things happen? Do you often have a signal that something has happened? I often wonder if we can give ML models a signal, just saying, "Hey, heads up! By the way, something is going to change," and you should, or are some of these changes like like secret sleuth? They come in and you don't even know.
Why don't you go first, Rama, since you have to leave at the...
Oh, thank you, James, and thank you all for accommodating my constraints today. On that one, both are possible, actually. I have seen instances where, when data changes, you can set up specific triggers to say there is an event that is likely to happen that will trigger a change, and therefore watch out for it and build models. I'll give one example. We had a financial services client who said, when they're launching an IPO of a company, there is going to be a lot of specific sets of actions that happen that initiate various IT transactions on systems. And sometimes in peak seasons of IPOs, they may have up to several dozens of IPOs going in the same week. So they want to be able to give a heads up to the IT operators and IT management folks that, hey, this is the load that's going to come up and the volumes are going to come up on the system, based on this IPO. And that is data volumes on, logs, metrics and all those things going for IT systems management, and where AI models have to monitor them. And also for cloud management, for scaling based on the load that's going to come up, they have to, prepare systems for it. So that is the one where you can plan and give a heads up on it. And also, when during Thanksgiving, retailers know exactly that their volumes go up, and they plan for scaling up and down, those sort of things. Again, that's a planned change that you can anticipate. But there are quite a few places and situations where you don't know how the data volumes are going to change, and also how they're going to drift. Sometimes, some of the customer preference related things, they may happen in a very subtle manner over a period of time. And, you need to be able to detect those data drifts. And also, in some situations when applications are running, I'm talking about IT examples, customer support, sometimes you don't know, you launched a new product and suddenly large volume of things start happening. People are calling in, and your chatbot system needs to be able to account for, recognizing all these accents from different folks coming in. Can you anticipate and plan? Maybe, maybe not. If there is a bug or a defect that's suddenly popping up, people are starting to call in and the volume increases. And based on that, you have to, new intents are coming up. Suddenly, you hadn't built a chatbot for that, and suddenly, battery is overheating, and that's a new intent that needs to be detected by the chatbot. And that may pop up, and after a few instances of those, the system has to quickly learn and make sure that it is able to recognize that intent. So both scenarios are possible, and I have seen all of those, anything in between in the spectrum.
Yeah, I totally agree with Rama. We've seen plenty of instances of both. So some examples of cases where the change is predictable is when you're introducing a new feature, when you're introducing a new capability, when you're introducing new network links, new data centers, things that you've got control over. When you're making a change to the environment, it's a change, but it's coming, so you can produce a signal that says, hey, it's coming. Most of those, you're trying to get the model corrected in advance for if it's coming or if something has changed. In most cases, it's something that you didn't anticipate that comes out and bites you. The clearest cut cases of those are some of the models that we've got for health and safety, like spam-based models, or like security models, account compromise models, things like that, because you have adversarial conditions where an attacker is attempting to get past your defenses, and you really can't predict when they're going to come up with a new attack vectors or what the attack vectors are going to look like. So in most often it's dynamic changes to what's going on in the world or the environment that you don't or can't anticipate, because if you could anticipate it, you can design it and build it into the model.
Right. So what do you do in that situation, Jim? Like in the case of the security breach or spam issue, what do you do there? Is there a manual intervention that is needed, or you just try to set up a very tight, fast learning loop somehow?
Well, I wish I could say that we had the super tight, fast learning loop down to a science to react to some of these things. Certainly, that's always the goal, is to anticipate as much as you can. But in a lot of cases, what we've got is ways for models to raise a red flag and get humans in the loop as quickly as possible, to page a human to come in and look. The anomaly detection models that say something weird is happening here. I don't know if it's right. I don't know if it's wrong. We're seeing unusual activity on this account, or we're seeing unusual activity for this company, this tenant. Is it good? Is it bad? When in doubt, page a humanoid and get humanoid judgment. But you don't want to rely on that, because paging a human takes time. Even if somebody's on call and they react to the page immediately, you got.
Yeah, I know you've had that pager in your pocket.
I always got the pager in my pocket.
I know you got the pager. So, but yeah, it's a huge cost.
Yeah, I mean, it's like 10 minutes, and when you're facing a security attack, 10 minutes is like an eternity. In 10 minutes, an attacker can egress or create a lot of havoc. So you always have the back door of calling in a humanoid,
right?
But you don't want to use it in a lot of these cases, because by the time you get them involved, you're dust.
Mm-hmm. So Christina, I have a question for as we're talking about these kind of examples of changes. You mentioned some examples to applications that are that might occur. That those ones, would you consider those as examples where you actually have advanced warning and you have signals?
Yeah, I would. So, I mean, you might not have a very advanced warning, but it's not something that happens unexpectedly, because you need to at least redeploy part of the application. So even if you don't have a human signal that this is about to change, this is something that the tracing system, for example, would learn, because they would see that the dependency graph of the application has changed. So yeah, I would consider that a programmed event, and then same with changing the underlying hardware. But you still
do you feel like we have a, sorry, do you feel like but I guess I wanted to ask you, do you feel like this change detection thing, or looking at the dependency graph of things, do you feel like there is a good solution to that, like a good standard way of dealing with that kind of change detection and the kinds of problems you're looking at?
Yeah, I mean, this will depend a lot on the area. For cloud applications and performance debugging, resource management, all the systems have tracing infrastructure in place, which has multiple goals, including tracking what is the path that requests follow through the system. So if you have an application that's not just a single component, but it's a graph of hundreds of components, what is the critical path? What is the most frequently used path? And then you need that information in order to optimize anything, either in the hardware or in the application design. That will depend a lot on the area. So maybe for other types of ML models, you don't have that tracing information, but at least for my field, that is something that you can assume.
Actually, as you're saying that, I'm realizing that the whole debugging and I guess what they call provenance areas are kind of well suited to machine learning, in that you keep track of a lot of stuff happening in the system. You log everything, right? More than you probably need, which is great for machine learning, at least as far as I know. And you're often trying to trace things down, like doing root cause analysis and things like that. So all of these things seem like quite useful platform tools that would be useful for ML.
Right, so it's an area where you have the data. You don't necessarily want a human to parse the data. And in fact, it's more of an issue of picking which of the data is useful instead of collecting enough data. You always have enough data.
Yeah. Martin, have you had any experience with these kinds of like debugging or tracing kind of problems or applications?
So the paper that I mentioned earlier about storage systems is exactly that kind of scenario where you have this distributed tracing information that you want to learn on, and yeah, I think it's a great area to work on.
Yeah, I agree that I feel like I mean from my I'm at I didn't tell really people where I'm from. I'm at Microsoft Research in New York, and I think that we have all these telemetry systems and tracing things, and I think that we're actually not leveraging all of them to their fullest when it comes to using them for our ML applications, because they're there and there's so much data. In fact, sometimes I'm surprised as a researcher that I have access to all these traces and I can look at all these systems and like, oh wow, I can see all these cool telemetry that different product teams and groups are using. And I think that's a great starting point for getting things like features and reward signals and things like that. That we're not quite. We don't have like one kind of standard way of using it for ML applications, but I think maybe we can get there. So I wanted to ask. So we're touching on all these like very classic ML issues, which is great. Very easy to get carried away with things like safety and non-stationarity and things like that. I do want to talk about safety a little later, but one of the topics of this panel was to talk a little bit about what's happening across industry and academia. And so I guess I wanted to maybe start with Christina and ask, you mentioned you had some nice collaborations with some industry partners and collaborators working on some of these, cloud AI problems. Can you tell me an idea of I know there are different levels of those kinds of collaborations, right? And I was wondering if you could kind of break down one of your experiences, whether it was just like a question of data exchange, or if it was a deeper collaboration, or if there was actual possible trying things out and deploying things involved. Can you give us your experience from the perspective of a university professor?
Sure. I can give you an example back from when I was a young student. This was back in 2014. So I did an internship at Twitter, and the goal was to see if you can automate part of the cluster management. So Twitter at the time was using Mesos, I believe they still do, but the interface between the user, not the end user, the Twitter engineer, and the system, the cluster manager, was reservation-based, which means that the user tells the system, I need that many resources, allocate me that many resources wherever you think they are available. And the problem with that is that people don't always have a good grasp of how many resources they need, even if they develop the application themselves. So what you have happening most of the time is that they'll ask for much more to avoid issues like interference or some unexpected spike or the worst case scenarios, or that they might be placed on a machine that's suboptimal for their application. So you end up with a system that's greatly underutilized. So at the time, I was at Stanford and we were doing this work on applying recommender system technology, so things like collaborative filtering, to understanding what are the resource requirements of applications that potentially you have not seen before. And the goal of the internship was to see if we can take some of these ideas and apply them at Twitter. So we were actually able to deploy some of them. It wasn't the full system, so the interface remained. The interface had a fallback mechanism that was reservation-based, but what we were able to do was essentially have the users express their performance requirements instead of resource, and then have the system translate that to resources. So there was a lot of skepticism initially on how that will work, and part of that is because, again, ML is often treated as a black box, so if you're not sure why you're getting the output that you're getting, you can't have a lot of confidence in the system. And that's exactly getting to your point about safety. That's exactly why we had a fallback mechanism where if the system did something that was unexpected, or if you didn't get the performance that you thought you were going to get, it had a fallback mechanism where you would be allocated the resources you asked for. But that was an example of a successful, I guess, idea transfer from academia to technology, where even though it wasn't the full system, the way we designed it initially, there was still a good chunk of the ML techniques that found their way in the production system.
And you were able to do this all during an internship?
Yeah, but I had more people that helped.
Okay. Oh, yeah. But managing. So just to get into like some of the logistics of it, like when you went back to university, I imagine the work still continued and deployments happened maybe after that, or was it happening during your internship itself?
So a first deployment to a smaller test cluster happened while I was doing the internship, and then to the production cluster it happened after. But the nice thing that came out of the internship, in addition to the deployment to production, was that I was able to get some data. And that's one of the nice ways that industry and academia can collaborate, by providing some motivation data, right? So as an academic, I believe that I know that something is an important problem, but I don't have access to the internal data. So by having a collaboration with industry, I can actually measure and have quantitative data that this is indeed a big problem. So even if the full research idea is not deployed in the production system, it's still very useful to have motivation data that proves that that is important.
Yeah, and I found it recently, and I mean, I haven't been at Microsoft as long as someone like Jim, but I was at Microsoft before my PhD, early 2000s, and I do remember comparing that time to now. I do find it easier to curate some data sets and release them. We have processes in place and a lot of kind of encouragement and to try to open source these kinds of things. And so I do feel like the landscape has changed. And I know what you're saying about just having access to those kinds of interesting data sets and being able to motivate your work. So that yeah. So I guess Martin, a question for you from the Google side: is it easy to how easy do you feel like it is to share data with university collaborators, or have you had experience working with university collaborators after you went to Google?
So I am collaborating with university, and I think a way to echo what Christina said, this can start is via an internship. So in this case, basically start as an internship, and we're continuing this collaboration now that the student is back at the university. And there are different ways of doing this. It depends a little bit on which kind of area it is in. For example, a lot of software is open source. So if it's on an open source project, that can be one way for this collaboration to work. You mentioned data sets. I think that is basically depends very specifically on a case-by-case basis. I mean, Google has released data sets, for example, the Google Cluster Traces as one example. But of course, that is always a case-by-case. And what I found is that for university collaborations, if you can work on an open data set, maybe an open source project, that is usually the easiest. And something that's possible, especially in machine learning, where a lot of the data sets that people are using are available in the open anyways, and they are basically standard sets that everyone agrees on. This is what models are evaluated against.
Jim, what is your point? What is your thought on this kind of on working on some of the ML problems that you face or see in the cloud, and dealing and working with university collaborators?
Well, in general, I've got half a dozen or a dozen collaborations going on at any given point in time. Most often, they're in the form of research fellowships or visiting professors. And the dominant reason behind that is exactly one of the points you're talking about here, which is data and access to data. The part of Microsoft that I have some responsibility for is Office, so the G Suite equivalent, where you've got companies' email and Word docs and Excel docs and PowerPoints and meetings and chats and things like that. And that's a case where it's not our data. It's data that belongs to our customer, that belongs to the tenant. And we can't share that data even if we want to. We can't give anybody who doesn't have the right data handling standards and the right non-disclosure agreements in place, which are usually horrifyingly draconian, is probably the best way to put it. We just can't share the data because it's not ours. We're not allowed to. They're horrifyingly draconian because it's some of the world's most valuable data. Pre-release financial information, merger and acquisition information, information like where important people are going to be and when. That would be great for things like political assassinations. And
I think you're describing basically third-party data, which is like our customers and like their data that we can't, right? Versus first-party, right. Maybe.
And we've got to be really careful with that. And even in the case where we think it's our data, like some of the service telemetry data, Is that through bugs or problems, is there a possibility some third-party data might leak into that? So the cases when we can really share the data is safely requires a lot of time, a lot of lead time, a lot of attention, because we've got to be dead certain we're not compromising any of this third-party data.
So let me interrupt you in that one, because I really like that question. So if you have a third-party customer running a service and you're collecting telemetry about their service in this kind of black boxy way, do you think that that data is something that is still somehow private to the customer?
It really depends.
Right? Yeah.
Anytime you're talking to somebody who works in a huge hosted service, the answer to every question is it depends. It's a fairly useless answer in most cases, but it's an honest answer.
Yeah.
So if we look at something that you think would be relatively innocuous, like what's the traffic volume coming from a certain customer? How often are they interacting with our service? That you would think, hey, that's pretty safe, that's pretty honest telemetry data. For a lot of attackers, they can infer things from the data. Like if you see a sudden drop, somebody's meeting. If you see a sudden surge in activity, they're talking a lot about something like that. So if you've watched a lot of bad political intrigue, that before a war starts, there's a sudden surge in communication as they try to coordinate what they're going to do. Where this type of telemetry would give an attacker knowledge about what's going on in that business or that political organization. We've got things like communications between prime ministers and their staffs. And you don't think that somebody would be interested in knowing, is there a sudden surge in how often the prime minister of Belarus is talking to his cabinet? Now, we don't really host them. That's a made-up example given the times, but it just shows how even innocuous-looking information is something that we got to just be cray-cray about protecting.
Right. That's really interesting. Those examples are, if you think about it, I see what you're saying, that it's, in the wrong hands, people who are determined to learn or infer, they might be able to. And I struggle with this myself. It's like this difference between like latent, what information is latent in there and leaking versus what is like practically usable. And it does depend on what people's intent is, right?
Yeah.
And how determined they are, I guess.
Yeah, and if they've got good intent, a lot of things are safe, but we really do have to worry about the adversarial cases a lot.
I like I think a lot of the success in transferring research ideas into product group, I think does rely on the safety of deploying a solution like that, whether it's ML based or not, or just some fancy new heuristic idea. So, and I really like what Christina said about having this kind of safety mechanism of fail-safe in place. This is something that I'm very interested in myself now. In fact, one of the things I'm trying to do today is look at all these different cloud teams and look at what fail-safe mechanisms they have in place. So I was wondering if we could spend a little time talking about that. If you could give me an example of your favorite fail-safe mechanism, a non-ML one, preferably. I'd love to hear about that. Like any system you worked on where you felt like there was a safety mechanism or fail-safe in place that you would have probably kept, even if you changed the core logic of the system to use fancy ML. I'm very interested in hearing about that. So, Christina, can you tell us what the fail-safe mechanism you were referring to at Twitter was?
Sure. So
and when it kicked in and when it backed off.
Yeah, so essentially what the research system did, so the new approach, was not having resource reservations, instead having the quality of service or SLA defined by the user, and then let the system handle the resource assignment to meet that performance target. Now, the initial design was that you have resource reservations. So the user tells the system, I need that many resources. So we switched to the performance-based approach, but had the resource reservations as a fallback mechanism. So let's say that the performance didn't meet the quality of service that the user specified, or you had some unexpected spike in user load. it would fall back to whatever amount of resources the user had asked for initially. And the reason for that is not so much because it was better, it was a better decision, but because then you can tell the user that, okay, if you don't get the performance, at least we gave you what you asked for, so it's on you. It's not on the system.
So this is an interesting point you're making. So do you think, and this is a question for Martin and Jim as well, do you think that safety is basically as good as the last deployed system? You know what I mean? Like the previous version, if you can guarantee like, oh, I'm not going to be worse than what we've had before this, is that a measure of safety that works? I know it's a little different in Christina's example because like you're actually giving them what they asked for, but in some sense, it's also an example of what I'm saying because it's the previous system, what was there before you put this new thing in, and you're saying, well, I'm at least giving you that. So how far does that go, I guess, is the question I have.
Yeah, that was safety because, again, you weren't making it worse than before. But, I mean, if you have something that's security or privacy critical, safety would be a different metric.
Right.
You want to go, Martin? You want me to go?
Go ahead.
All right. I think that, again, answer to everything, it depends. If we've got a case like a new attack vector coming in, falling back to the previous model that you know they've already compromised, isn't a good enough bar for what we're talking about in a lot of these cases. If we go outside of that domain, the results of the previous model generally are a good surrogate for a good enough bar in a great many percentage of cases. So that's always one of our starting positions is do no additional harm. Don't make it any worse. And that doesn't necessarily mean you can fall back to the old model in all cases either, even if you've got one. But as long as the results are at least as good, then that is it's table stakes to move a model from the innermost ring of deployment where it's exposed to a small number of people to further rings of deployment where it gets progressively extended out to more and more people. That notion of rings of deployment of new versions and changes is something that we've got, and I think most major cloud vendors do, where you don't Donkey Kong something out to the whole world all at once because a screw up then brings down the whole world all at once. You generally have rings of deployment where you increase the percentage of people who it's exposed to.
And I guess you're saying that like matching previous performances, maybe one signal that you can move to the next ring.
That's right. That's exactly right. It's one of many signals that you can move to the next ring. But it's one of the ways that we have that provide some of that safety is it might not be safest for the innermost ring, but you're going to stop it before it gets to affect a significant percent of your user base.
You know, and in your bio, I know you mentioned different kinds of AI applications you worked on. You also you mentioned the focused inbox in one of them, and I was just wondering, do you remember if there was any fail-safe mechanism put in place to protect like a manual rule or something along the lines of what we talked about earlier in the panel that was put into place into that system or a similar system to protect from some downside? Yeah,
the feature you're talking about, Sid, just to make sure everybody's following along with the program
please tell them what it
is within Outlook, we've got a feature called focused inbox or focused other, where we use an AI model to analyze your inbound email and say, is this something that we want to put in front of you sooner rather than later because it's something you should focus on, or is it something where it's something you get copied on, but maybe you're not going to act on it. Maybe it's not as important to you. It's not spam. It's not garbage. It's something real that's intended for you, but it's something that statistically, based on these models, you're less likely to read. You're less likely to read quick. You're less likely to act on. So we take it out of your immediate view, so that what you see in the immediate view is stuff that you should quote unquote focus on. And in that case, we had a bunch of different fallback and safety mechanisms for it. from dropping back to the previous model, to Christina's point, that do no additional harm is a good starting point, to scenario-dependent fallback models. Like in the worst case, the risk is you put something important in this look at it later pile. So we said, worst case, you revert to put everything in the look at it now pile. And you might get grumpy because there's more stuff there that you don't need to focus on that's in your face, but you're not going to miss anything important. A lot of this is really about knowing the consequences of a wrong decision by the AI, and then having defensive and security measures in place that are appropriate for and tailored for that what happens if it screws up consequence.
Got it. Martin, did you want to add anything there?
So I think there is a general pattern, and this goes back to this decomposing problems into a learned part and the heuristic part. When you design this heuristic part that makes use of the learned information, it oftentimes needs to take into account that the predictions could be wrong. And to give one example, we had a research paper on machine learning for memory allocation, where the learned part was, so this was in just a normal C++ memory allocator. At the time you allocate an object, you predict what is the lifetime of that object going to be, and then you have a heuristic that groups objects by lifetime to save memory. And how do you detect that the prediction was wrong? Well, you have a prediction, and if you're off by a factor of 2 or 4 or something, so you say this is going to live for 1 second, and it has been there for 4 seconds, you can be pretty sure it's wrong. And so the heuristic that puts things together based on the predicted lifetimes can actually detect when one of your predictions was definitely wrong because something has been around for much, much longer than it was supposed to. And then it dynamically adjusts and reclassifies things and say, okay, throw away the old predictions, let's assume they were wrong, and reshuffle things based on that. And I think that pattern applies in lots of places where you just basically need to have a way to detect when you were wrong and then recover.
I see. Yeah, so in situations where you have that feedback signal, that can be a great way to to realize, oh, something went bad, and I need to do something different. Got it. I noticed there's a question in the chat, and maybe it's a fine topic to end on. We do have just a couple minutes left before we're going to get yanked out by force. So this question was about the explainability, transparency aspects of AI models in industry versus in academia. And we touched on a little bit in the earlier part of the discussion. Does anyone want to comment on how important explainability is in their context, or how much they think about it?
Oh boy! If you could give me universally explainable models, I would chop off major body parts and mail them to you.
Oh wow, that's a big. Well, I can give you one. I can give you a humanoid that's there for you all the time to tell you what they're doing.
Yeah, I mean, increasingly, in a lot of cases, we're facing legal and regulatory scrutiny about the results of AI operations and the consequences that they have on people and society. And we have to spend a fair amount of time talking to legislators and regulators about what AI is, what it does, and how it operates, because they're very concerned about the adverse societal effects of doing it. And being able to explain it not to another engineer, not to another scientist, but to a generic human, or to a politician or a lawyer, and you can argue whether they're humans or not. And that would be unbelievably important and valuable as an industrial, as a breakthrough for the science, for AI at large. Because the challenge we face in the case of a lot of these models that have consequences is that the existing data and saying, hey, we're producing the same results that would have been produced in the past through the existing processes, through human processes, it's not good enough.
Right.
They want models that match a societal ideal, not what currently happens in the world. And so we can't even use data to train it that hasn't been scrutinized to say, hey, is this data that's going to produce results that match a societal ideal?
I think that's really a great point, Jim, and probably a great point for us to end on, because I see that we have about 11 seconds left before we get booted out. But thank you so much for that point, Jim, to end on a great note. And thank you to all our panelists. Thank you, Christina, Martin, Jim, Rama, and Niraj, who couldn't